This is a video on surface area. The question states, find the area of the part of the surface z equals x squared plus 2y that lies above the triangle with vertices 0, 0, 1, 0, and 0, 1. So let's start by recalling the formula for the surface area that says that the surface area below a curve defined by z equals f of xy above a region is equal to the double integral over that region of the square root of 1 plus the partial derivative of f with respect to x squared plus the partial derivative of f with respect to y squared dA. So in our case, f sub x is the partial derivative of x squared plus 2y, and that's just 2x. And I call that z sub x, the partial derivative of z with respect to x. F sub y is z sub y, which is just 2. So now let's sketch the diagram. We have a triangle, so I write my vertices 0, 0, 1, 0, and 0, 1, and I get this triangle. And note that this top curve that bounds the triangle is y equals 1 minus x. It's a line with y-intercept 1 and slope negative 1. So I put my little man in, and notice that the feet of the little man are at y equals 0. The head of the little man is at y equals 1 minus x. The farthest left the little man gets is x equals 0, and the farthest right is x equals 1. So I can put all of this together and say that the surface area is equal to the double integral from x equals 0 to x equals 1, from y equals 0 to y equals 1 minus x, of the square root of 1 plus f sub x squared, which is 2x quantity squared, plus f sub y squared, which is just 2 squared, dy dx. At this point, I could simplify this out and write this as the square root of 5 plus 4x squared, and then do an arctangent substitution, and then do some amazing integration techniques that you would find very difficult, and so would I actually, and come up with an answer. But instead, I did the easy way, and I used a calculator, and I got that the surface area is about equal to 1.19. And I'm done with the problem.